Hello, everyone. My name is Wang. I'm come from Xuesong University of Technology. It is with pleasure that I'm presenting this talk today in the first in the International Conference of Fracture and Structure Integrity. The focus of my work will be on the resource distribution. Uh, of high-strength steel, multipass butt-welded joint, considering the strength mismatch effect. I'd like to acknowledge that the support of the funding of the fundamental agency and industry partners. The particular presentation is about the strength mismatch effect on restaurant stress distribution. I will talk from the four aspects. The first one is the motivation. Um, the the background and the motivation for the work, as many as you may know, within the future industry development. Uh, One of the effective way to enhance the lightweight of the structure to increase the structure of steel for decreasing the thickness of the plan. It is dealing with a conventional material. Uh, how about the structure performance considering the welding processing? I think it is very problem. It is very important for uh, the structure service uh, under some special conditions. For the welded joint of hydrogen steel, there are some problems such as the hydrogen introduced cracking, softening of the HVAC, and decline of softness. So we can use some different solution to uh, solve that problems. One direction is about the welding processing, just like using the lower energy or doing the preheating treatment or the post-heat treatment. Another strategy is using the different welded materials. Uh, yes, just like the mismatch the materials. So for these materials, how about the resource rates? It is very important to access the distribution, which is influenced by which affect the uh, fatigue properties of the welded joint. So this study aims to investigate in the resource distribution of even matched material and unmatched material, and the SSPT effect on the resource distribution. The third is the backchipping processing effect on the multi-pass but welded joint. So I think the possible application of this study is that it can be used in the integrity assessment of the welded structures, and also it and another advantage is that we can optimize the welding processing of the welded joint or component. So for the experiment of welded joint, we choose two weldment for the welding joint, the which is the even matched weld and the undermatched weld. So from the cyclic loading, from the result of the uh, stress strain curves under static and cyclic loading, the property has been given in this table. Thus, we can see the undermatched yield strength is lower than the base metal. So the undermatched ratio is about 0.5, and even matched uh, ratio is the 1. This figure is showing the welded plan schedule and the actual multipass welded joint with a V group by different welding processing for even matched and undermatched welded joint. So the body welded joints uh, uh, were fabricated by the single blast gas metal arc welding processing for the even matched configuration using the corresponding weld, and while the gas material arc welding processing was performing for the unmatched welded joint by the lower strength filler material. And this is the FEA models in the ABAX. So we established it uh, 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 according to the actual weldment. As you know, welding is a complex joining process including the multiple physical interactions among the thermal, mechanical, and metallurgical fields. The interaction relationship among the three fields are demonstrated in the figure. So the numerical simulation procedure to realize the interaction between the among these fields can be highly complicated and challenging to obtain satisfactory result considering some aspects. So it is necessary to clearly illustrate and solve the complexity of the welding simulation by an efficient, precise model. So the filament element method is utilized to realize the complex in the welding processing considering the microstructure and the mechanical evolution as the transient thermal field variation in our study. So these figures are the microstructure characteristic characteristic validation. So we can use this microstructure to uh, uh, demonstrate the relationship between the metallurgical and the mechanical. Uh, this page is about the material properties, about the thermal and the physical uh, aspect. So we some properties were obtained by the experimental uh, test. So after that, we established the mm, relate uh, relate the user subroutine codes to compute the uh, compute the resource rates and the thermal files. This is the result of resource rate distribution about the even matched welded joint, and from this result we can see that uh, uh, the resource stress distribution considering the SSPD effect, gives the good agreement with the experimental data uh, in the longitudinal resource stress and for the uh, 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 transverse residual stress, it also can see the same conclusion uh, from the figure. So the calculated residual stress based on the SSPT model are slightly underestimated in the fusion zone compared with the experimental result. Um, this is the unmatched welded joint using the considering the SSPT or not considering the SSPT effect. So there's no obvious differences between this result. The residual stress near the interface exists a great discrepancy attributed to the yield stress mismatch of beam and film materials from the figures. So and um, last last page, I just to check the back chipping effect on the welding residual stress. The residual stress distribution of the back area cannot affect its variations of the front surface in the welded plane after the back chipping processing. So I think we can summarize three conclusions. The first one is consider SSPT and the yield stress variation in the value processing effectively. It enhanced the computational process of the residual stress. The even matched filler material can induce great compressive residual stress in the welded zone, while the result in unmatched welded joint show tension residual stress without the consideration of the SSPD effect. The second point is that the mismatch effect of material yield strength on residual stress distribution is significant for longitudinal direction than the transverse direction. The residual stress distributions considering the SSPD effect will exert a considerable contrast in both longitudinal and the transverse directions by comparison between the EM and the UM welded joint. The third is about the backchipping processing in multipass welded joint shows a great influence on the final residual stress distribution. It is not only can alert the residual stress distribution tendency, but also change the maximum multi magnitude of back welding regions for EM welded joint due to the SSPT effect. Okay, thanks for your attention.